Okay, well, we're going to take a look at three variations of mixture problems that we're going to solve as a system of equations. The first one, let's just go ahead and read the problem. It says, two small pitchers and one large pitcher can hold 8 cups of water, and one large pitcher minus one small pitcher constitutes 2 cups of water. How many cups of water can each pitcher hold? Well, I think the first thing that we should do whenever we approach a word problem that we're going to try to solve by algebra is to try to identify what the unknowns are and determine what letter we're going to let represent that unknown. And so, for example, in this problem, it makes sense to just call the small pitcher, which we don't know the volume of, that's the unknown, but let's just call that S. Okay, so that's going to be the small pitcher. And let's go ahead and call the large pitcher L, and these are the number of cups of water that fit in each of these. Okay, so now we have to establish some equations, and generally speaking, when we're looking at a mixture problem, you usually end up with either value equations where a combination of items are worth a certain amount. Doesn't have to be money, it could be total number of points or something. And then there's relationship equations. You're comparing how much of one thing you have to another. Or you have some kind of a quantity situation where you're saying that this item plus that item equals a total amount. So we're going to see a variation of these things as we go through these three different problems. But in this particular one, we have two small pitchers and one large pitcher can hold 8 cups of water. So I think we got a value equation there. We could say that 2S plus 1L is equal to 8. That's the total value. And so there's one equation. 2S plus 1L is equal to 8. Then the other equation, we need at least 2 equations if we have 2 unknowns. Let's go ahead and read this second one. It says one large pitcher minus one small pitcher constitutes 2 cups of water. So that would be 1L minus 1S is equal to 2. All right, now we got our system, and now it isn't so much that we have a word problem, it's just how do we go ahead and solve the system, and we have a couple of algebraic methods. Both the substitution or the addition method would work here, but I think just because it'd be so easy to solve one of these equations for a letter, let's try this by substitution. So I'm going to solve this bottom equation for L, and I would get that L, if I added S to the other side, is equal to S plus 2. And then with substitution, once you have one equation solved for a letter, I'm going to substitute that value in for L in the other equation. So I'm going to bring this equation over here. And instead of writing 2S plus 1L equals 8, I'll write 2S plus what 1L is equal to, which is S plus 2. So I'm going to put that in there. S plus 2 is equal to 8. I just replaced L with S plus 2. And now I could go ahead and solve this for the value of the small pitcher, how many cups are in a small pitcher. So I have 2S plus 1S is 3S, plus 2 is equal to 8. If I subtracted 2 over to here, I'd have 3S is equal to 6. And if I divided by 3, I'd have S, or the small pitcher, holds 2 cups. And then as we know with substitution, once we have the value for the first letter, we usually go back here to find the value of the second letter. And so for that equation, L would now equal, instead of just S plus 2, I could now put the value of the small pitcher, which is 2, and we end up with 4 cups in the large pitcher. Okay, so that's that problem. Let's try another one. So here's another variation on mixture. Okay, so we got it. Test has 20 questions worth 100 points. The test consists of true and false questions worth 3 points and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? Okay, so we don't know how many of each kind there are, but we do know that the test has 20 questions. And we do know that they're made up of true and false and multiple choice questions. So let's just call T the number of true and false questions. And let's say that M is the number of multiple choice questions. Okay. So now that I've established what my variables represent, let's just go ahead and write the equations. And we said, again, with a mixture problem, I might have a value equation, I might have a quantity equation coming from several different sentences in the problem. And in this particular case, right up front, if I know the test has 20 questions, then I know that the total of the number of true and false and the number of multiple choice should give me that 20. By the way, I don't want to do too much at one time. You don't want to try to get an equation that has both 20 and 100. That's a value. This is a quantity. I'm going to keep those separate for a minute and say that T plus M, just their quantities, not their value of points, equals 20. But now, with that 100 points, I could say this according to the values associated with true and false questions, 3 points each, and with multiple choice questions, 11 points each. I could write a value equation, and I could say, well, every one of those true and false questions, which is represented by T number of questions, times 3 should give you the number of points contributed to the test by true and false questions. Plus, if every multiple choice question is worth 11, then I can multiply 11 times the number of multiple choice questions, which was M, and that would be the value of points associated with multiple choice questions. And when you add all those points together, you should get the 100. So now I have two equations. I have this one from quantity, 20 questions, and this one from value of 100 points. Now I'm going to pull those together. So I'm going to put these underneath each other. And maybe this would be a nice problem to solve by the addition method, just because I have nice columns here of T, M, and points, right? And so I need to eliminate. That's what the addition method does. It eliminates a letter by getting the values in front of that letter to be equal but opposite. So I think I'm going to have to multiply this equation by -3. I better seal that off there. So I'm going to multiply this whole equation by -3. That'll allow the T part to go ahead and cancel when we add this column. And so I'm just going to carry the top equation over, 3T plus 11M is equal to 100. But this one I'm going to multiply by -3, and I'll get -3T and -3M. And don't forget to multiply the right-hand side, -60. -3 times 20 is -60. Now I'm going to add. And when I do that, column goes away, which we planned on. And this gives me 8M. And this equals 40. I divide by 8. And I get the number of multiple choice questions were 5 questions, right? Not 5 points. 5 questions worth 11 points each. Okay, so I go back and I find an equation that I could solve for T, and it looks like this is a really nice equation to do that with, really simple. So I'll say T plus, and instead of putting M, I'll put what M is worth, 5. And when I subtract the 5 from both sides, I'll get that there were a total of 15 true and false questions and 15 true and false questions and 5 multiple choice questions, giving me the 20 questions. I think I'll stop there, and on the next video we'll go ahead and take a look at some other problems that are related to solving a word problem by a system of equations.